Thank you, thank you, thank you. Good morning, everybody. I'm so excited to be here with you all today, but I'm also conscious that we have very little time in which to get done what we need to get done. So, that said, my name is Josh. I work on the Spring team. I'm a Spring developer advocate, a Kotlin Google developer expert, and a Java champion. And most embarrassingly, look, I'm not proud. We all do things we're not proud of for money. I am a YouTuber, okay? So you can find me here on the YouTubes. It's not great, okay? I'm just gonna level with you. You will make worse mistakes in your life. Not many, but surely some. Then decide, like and subscribe right there. It's an adventure. It's an adventure. That's how I like to think about it. It makes it feel more adventurous for me. So like and subscribe. Join me on the internet. Who uses the internet? Anybody here? No? All right. Then I expect at least as many likes and subscribers as there are people in this room. Friends, look, I'm really excited. I wanted to talk to you about all the cool stuff on which we're working today. Oh, by the way, anybody using email? Email? I forgot. Yeah, find me there. What about Blue Sky? You don't really need to go online for that. You got them right outside your doors here. It's a beautiful city. But what about the Bird website? No? Okay, good. Moving on. I guess I've been seeing some of the things that you locals lovingly refer to as chickens here that are definitely not in any sane context chickens. They are tiny dinosaurs. Remember that. They are not to be trifled with. And of course, the code, which we're going to look at today, is here. So should you have questions, comments, feedback, don't worry. Our time extends long beyond our brief 45-minute window together. And I'll be out and about outside the room answering questions. But even there, if you should have questions, don't hesitate to find me on these coordinates, okay? Take photos, do the thing that gives you the ability to retain this information. Okay, moving on. So I was really kind of wondering what I could show you to sort of better demonstrate all the cool stuff on which we were working. And of course, there is the famous Spring Pet Clinic example. This example is a sample application that demonstrates a lot of the moving parts in the Spring ecosystem. And it's a very old project. It's like 20 years old, but don't think it's actually 20 years old. There's been updates more recently and so on. But that said, I thought we could show that, and it's a good idea, but it's a lot of moving parts, and I don't think we have enough time to really get into all of it. So I wanted to show something abbreviated, but in the same spirit. And I thought, well, we could do something about animals, you know? I love animals. Everybody loves animals, dogs and cats and so on. I love animals. I do. I just not my dog. He's terrible. He's a terrible, terrible dog. He's the worst dog. His name is Peanut, and Peanut he's not a good boy. Not a good boy, just a terrible, terrible dog. And there are 3 reasons we keep him in my home, okay? I'll just be honest with you. There's 3 reasons we keep him. Number 1, first and foremost, paramount among reasons, is, of course, even terrible, terrible dogs deserve loving homes, okay? Bad dogs deserve good homes. That's a fact, straight up. I'm not going to mince words there. That's number 1. Number 2, and this is, I'm just gonna be real with y'all. Just gonna be real. It's ego, okay? Look, in my home, my partner and my daughter both speak 5 languages. But 3.5. So if we got rid of that stupid dog, I would be the stupidest in the house. That cannot stand. That cannot stand. It will not stand, okay? So we keep the dog for that reason. And then the third reason, finally, is, come on. He is pretty stinking cute, right? He's so cute. He's so cute, but evil. Straight evil, pure malice. This is the best way to experience Peanut the dog via a photo on a screen on a different continent, okay? It's the safest way to do it, okay? There's no other way I would recommend in experiencing the dog that is Peanut. And Peanut, terrible though he is, he reminds me of another dog about which I learned during the pandemic named Prancer. And this woman, she put up an advert soliciting a new home for her dog in the pandemic in 2021, right there, right? And this dog's name is Prancer, and she described this dog very hilariously, and this ad went viral. She said, I've tried for the last several months to post this dog for adoption and make him sound palatable. The problem is he's just not. There's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins. She continues, I have to believe there's someone out there for Prancer because I'm tired, and so is my family. Every day we live in the grips of the demonic Chihuahua hellscape he has created in our home. If you own a Chihuahua, you probably know what I'm talking about. He's literally the Chihuahua meme that describes them as being 50% hate and 50% tremble. If you're intrigued and horrified, then, wait, there's more. She continues, she says, I was excited to see him come out of his shell and become a real dog. I'm convinced at this point that he's not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home. And she continues, this dog wants to be your only child, right? So, very ominous description of a dog, and I thought, well, wouldn't it be great if we could build a service to support adopting even this terrible, terrible dog? And so let's do that, as always, by going to my second favorite place on the internet. Obviously, my first favorite place is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. But if you've never been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a new service, my friends, and we have some questions that we need to fill out before we can get underway. First and foremost, what do we want to call this service? Well, I'm going to call it service. And the reason is because I'm amazing with names. Amazing with names. I get that from my father. My father was amazing with names. When I was a small boy, we had a small white dog, and my father named him White Dog. Amazing. Amazing with names. That said, my mom, she always tells me, she says, "You're very lucky that I named you." And yeah, that's probably true. One can only wonder what my father would have named. Well, you know. Anyway, autocomplete that for yourself. So anyway, there's that. We've got a choice of what Java version we want to use, friends. There are 3 radio boxes, but only 2 valid choices. Okay? In no context should you ever choose Java 17. It's completely inappropriate in every single context. It's not done in polite company. So we won't be using that. Java 21 is the long-term supported version of Java, and it is, in my estimation, the single largest release to come out of the Java team in decades, perhaps ever. It's an amazing, amazing release. So at least Java 21, right? Java 21 is amazing. It's technically superior in every way. It's faster, more robust, more syntax-rich, more operations-friendly, more performant. It's technically superior in every way. It's also morally superior. You won't like the look of sadness and shame in your children's eyes when they see that you're using Java 17 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use at least Java 21 or later. And friends, look, we're barreling down the road to Java 24. It'll be here in a few short months. And when it arrives, friends, we can say that not only is Java 24 better than, say, Java 8, which some of you I know are clinging on to. It's not just better than Java 8. It's 3 times. Let the math do the talking. It's 3 times better than Java 8. Okay? Mathematically, it's provable. So, I'm happy with that. We have to add some dependencies. We're going to use GraalVM. We're going to use the Spring Web support. I'm going to use Spring Modular to support building modular applications. I'm going to use the Spring Boot dev tools to make live reloading pretty quick. I'm going to use Postgres, but I want a Postgres plus some vector store capabilities. So I'll bring in that. It's 2024, and the search for intelligence has gone abysmally. So we now turn to artificial intelligence. We're going to bring in Spring OpenAI support. And I think we also need an ORM of some sort, so I'll bring in Spring Data JDBC. Now, I'm pretty satisfied with my selections. Let's go ahead and hit Generate and open this up in our IDE. It doesn't all that much matter which IDE you use, so long as it supports the build tool of your specification and the version of Java, all of which are possible in any of the modern tools. Okay, friends, so this is a brand new application. It's going to talk to a database that I've already got running in my local machine, so I need to specify some connectivity information here, right? So Spring Data Source, come on, Spring Data Source URL, JDBC, Postgres, QL localhost, my database, yeah? And we're going to create a username. Username, oh, come on, username is my user. And secret, now don't tell anybody, okay, this is between us, is called secret, okay? I'm going to use the little button there, click test connection, I'm going to hit apply, hit OK. I'm going to go over here, refresh this, IntelliJ makes this fast. It's really, look at that. I've like only 20 clicks and I have access to my table. There we go. So there's this table called dog, okay? And we've got the IDs, the names, the descriptions, the owners, and other information. Here's our boy, Prancer. His ID is 45. His name is Prancer. He's described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. And of course, his owner is missing. There's no owner yet. That's our goal. We're going to fix that today, okay? We're going to adopt this terrible, terrible dog. Now, what we have to do is we have to build some software. But friends, I want to build software in such a way as to promote modularity. Modularity is not a technical concern. It's a social political concern. I want to write my code in such a way that I reduce the blast radius of change. When I make changes to my code base, there should not be lots of cascading ripple effects that affect other parts of the organization. It should be well contained, well modularized, right? So we want to do so in such a way as to limit the blast radius of change, to make it easy to move and change and refactor with impunity. The faster you can do that, the less you have to have those tedious conversations with other people to synchronize those changes. The faster you can move. This is the rationale, by the way, for microservices, right? Microservices are a forcing function that give you an API inside of which you can do whatever you want, so long as the stable surface area of that API stays the same. right? This is not about tech. It's about moving faster as an organization. And the same applies even when you're just building software in a monolithic, modular sort of way. So we're going to do that today. And we're going to build a new module. And when I say module, I'm going to use that interchangeably here with the idea of a root package. So I'm going to create a new package here called adoptions, okay? Adoptions. And in there, I'll create a new class called DOGAdoptionController. And first things first, get rid of that public keyword. It's almost never necessary. We're going to get rid of that. I'm going to say @responseBody. This is going to be a controller. It, in turn, is going to delegate to a dog adoption service. And this is going to be a Spring Bean. It's going to be a service. And that, in turn, in order for it to do its work, I'm going to need to have some way of describing the entity. So I'll create a dog entity here, right, like this. String name, string description, and string owner, okay? And of course, this is going to have a primary key, which I'll map to my database table. And I'm using Java records. I love, 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 love Java records. I'm a huge, huge fan. Big fan, okay? Huge fan. Big, big, big fan. So there's that. I'm going to create a repository to get rid of the data access concerns so I can move on to the business logic that matters here. Okay, I think I'm happy with that. Let's actually flesh out this logic here. I'll have the ability, given a dog ID, and an owner name, I'll have the ability to update the dog record to reflect the fact that we have updated it, we've adopted it, right? So this is going to be a service. It'll be transactional, surely. We'll go down here and we'll flesh out this code. We're going to have a method here that will use that repository. Do you want to see a new feature that they added to IntelliJ that I just think is pretty wild? Watch this. Dog repository. Dog repository. Nope, that didn't do it. Dog repository. There you go. Look at that. Do you see that? Boom. It just added the constructor, added the field. I didn't even have to make the field itself. I have to do that. And so I'm going to say find the dog, find by ID, dog ID. If it's present, then I'll have the dog, and I'm going to update it. I'll create a new dog reflecting the new updated fields here, passing in dog.id, dog.name, dog.description, and of course the new owner from the method that gets called there. And I'm going to just save this out. I'll say dog repository.save, like so, pass this back, here we go, and I'll print out just to confirm that we've adopted this dog, yeah? Okay, so new dog, voila. And in order for this to work, I need to actually connect that to a HTTP endpoint, so I'll do that now. I'll create an endpoint called dogs, passing in the dog ID, and then we'll have the adoptions collection there. We'll just do void adopt. And we're going to take in, as part of our data, as part of the HTTP request, the dog ID, and data that's going to come in from an HTTP JSON payload will be used to extract out the name, okay? So there's that map, and I'll mark this as the request body, and I'm going to inject, again, I'm still trying to get used to this feature, right? So dog adoption service, oh, that's so good. Look at that, did you see that? I just added the field, and it created the constructor and everything. Annoying that it's public, though. Okay, so I think we're good. I think we have everything we need. Let's go ahead and start this application up. Here we go. Okay, and if I go to the console here, curl, there it is, curl -d, name is Josh, content type application JSON, localhost 80, 80, 45, dogs, ID is 45, that's Prancer, adoptions. Hit enter, and we got, looks like I've adopted the dog. Fabu, right? It's worked. Now we can confirm as much by going here and confirming that the owner field now says Josh. It works. Not all that interesting, but it does work. Now, to be fair, this is a bit of a contrived example. In most jurisdictions, you can't take ownership or possession of a live animal just by updating some field in some database somewhere. There's typically more bureaucracy involved. You might need, for example, to schedule a trip to the veterinarian, right, to get the poor dog checked out. So I'm going to create another module here called vet. So we're going to call this vet. And in there, we're going to have a class, a service to represent the veterinarian. But a veterinarian, is a... You know what it is, actually? You know what it is? It's a doctor for dogs. So we shall call this dog tour, okay? And at service, public void checkup int dog ID. Here we go. And I'm just going to print out, checking, scheduling checkup for this dog ID, okay? And I'm going to use that back here in my controller. I'll go back here, and I'm going to add this to the, the service. I'm going to do that in the service. Where's my service? Here we go. I'll add private final dog tour, add that to the constructor, and I'll go down here. And now, after I've scheduled it, after I've saved the updated state, I'm going to call dogtour.checkup, passing that in. And now I can go back here, refresh, and it says scheduling checkup for 45 and adopted, right? So isn't that nice? I've done both things, but actually, come to think of it, I don't really like what I just did here, because what I've done is I've added this collaborating object to my service. I've now risked muddying the concerns here. I've got too many things going on in this one service because I need to schedule the checkup, but I don't depend on the outcome of that. It's fire and forget. I really don't care that it gets done. It needs to happen, but it's not my concern. It's coincident. It's not a dependent, right? So maybe this is not the best way to do it. Maybe I need to think about how I integrate these two concerns in the system without having direct coupling. You can, if the occasion should require it, have a direct injection of another thing in another module, but if you can reduce that coupling, it's always good to do so. So let's look at a different approach to integration, one that is, I think, based on event-driven architecture and messaging. And when I think about that, I'm reminded of this wonderful blog by Martin Fowler. This blog was written in, come on, internet, do the thing. We talked about this. Okay, there you go. It says, what do you mean by event-driven? And it was written in 2017, before the COVID pandemic, or BC. And this blog asks the question, what do you mean by event-driven? It talks about 4 different styles of architecture. Event notifications, where you send to another system or service the fact of the event, not the details associated with it, but presumably the fact of the event is enough for you to do something useful with the event. So for example, if you program JavaScript, I'm sorry. I just am. I'm really sad for you. That sucks. But if you do, then you know that there's an onload listener. And the onload listener tells you that the document has been loaded. Which document? The one. You don't need any pointer to it. You don't need it in the event itself. You don't need extra context. You know which one. That's all. It's the only one. We can ignore iframes in this discussion, okay? Don't come at me with that. So anyway, that's a good example, right? Moving on. Event carried state transfer is where you send an event from one system to a service to another and give actionable context in the event so that the system or service that gets the message can do something with that, right? This avoids them having to make a query to the source system. It makes it so that they're completely decoupled. If I can take actionable behavior based on the event that I get, then I'm completely decoupled from the producer. I don't know who sent it. I don't even know how to get more information from the producer. I don't care. This is quite nice. And if you do that, if you realize that if you start communicating all state changes in the system via events, then something really wonderful happens. The single source of truth in your architecture is the set of events that you've been given. So suppose you have a multi-data structure system with a Redis for fast read-only constant time lookups, and you've got Elasticsearch for full text search, and you've got a Postgres for transactional sort of line of business kind of rights and all that stuff. In this system, I can't reconstitute each of those things from each other. The only thing I can use to reconstitute all of them is the events. And if you understand that implication, then you understand event sourcing. It's the idea that the events are the only source of truth in the system. And if you delete Postgres and Redis and Elasticsearch and install them all brand new with empty data, and then republish all the same events in the same order as which they were originally received, you'll get the same Redis, the same Postgres, and the same Elasticsearch. That's called event sourcing. And this event sourcing plays really nicely with the insight that most systems, even monolithic systems like the one we're building right now, have multiple data sources. Data structures optimized for different read and write modalities. And if you understand that, that's called CQRS. Congratulations. If you understand all 4 of those patterns, you're an architect. Collect your promotion at the door, okay? So we're in a good place. We now have a good understanding of why we can use event-driven programming. So I'm going to use event-driven programming here. I'm going to back out this change to the DOGtour, remove that from the class here, and I'm going to inject the Spring Framework application event publisher, okay? And this is a thing that's been in Spring for 20 plus years. If you look at this is actually from Spring Framework 1.1, right? So Spring Framework 1.1, let me just go ahead and use it. I'm going to publish an event. And you might be wondering, what event? Well, friends, this is where we get to make our first deliberately public type. I'm going to create a class called the dog adoption event. This is a public type, okay? I'm going to export this from one module to another. And I'm going to publish that event here. I'll say new dog adoption event. Here we go, passing in the dog ID. And I'm happy with this. I think we did a good job there. I'm going to go back to my DOGtour class now, right over here. And now that I've published the event, I don't have to make the type itself public. I can make the event public. I can back out that stuff there, and I can make this a Spring Framework event listener while also correcting the spelling here, okay? So let's try that out now. Let's see if it still works. So if I restart that, where's my console here? Scheduling, correctly spelled, checking up for dog adoption event. So it's worked. I've used messaging to decompose these 2 things, okay? They don't know about each other now. They just know about the event. That's the only thing that we've made public. Remember, public is a problem. You don't want public. Whenever you can avoid it, reduce the scope of your changes in the code base. Public is bad. People can depend on things that are public. You don't want that, right? So I've made an effort here to keep things not public as much as I can. And this is very much I see this anti-pattern all the time. You see like app.controllers, app.services, dot app.repositories dot, right? And then app.models dot, right? This is an empty pattern. I think we cargo culted this from the Ruby on Rails community. When have we ever cargo culted anything from them that we should have? No, let's not. Especially not this. This is a terrible pattern. In order for this scheme to work, every class must be public, save perhaps the controller, right? Don't do this. Instead, flip everything, flip the layers 90 degrees and do app.customers. And then just put the controller, the service, the repository, and the model in the same thing. That way they can all be packaged private. This is a much better scheme because now things are packaged private and they're logically encapsulated, as you should do. Remember, Java is an object-oriented language. You get information hiding. The goal of information hiding is to reduce the scope of change, to reduce the blast radius of change. If you want everything to be public and you want everything to exist in a flat global namespace, just use C. What's the point? Why bother wrapping it in Java ceremony if you're going to get none of the benefits of it? Just use C. So don't do that. I'm going to keep things nice and decoupled, okay? So I quite like this. This is nice, but are we as decoupled as we think? Well, not really, right? Because what I've got here is this event listener annotation. I'm dispatching an event from one module to another, and they're getting dispatched synchronously in the same thread, okay? This is good if you want things to happen in the same transaction, but it's bad if you want things to happen in a sort of decoupled, asynchronous way. There's implications for that. If I had thread.sleep in here, for example, then that means that the dispatch would actually block waiting for this thread.sleep to continue. I would hit the adopt endpoint, and I would wait 5 seconds for this to actually get dispatched. So let's go ahead and try that out here, okay? So start, and I'll go down here, stop, and then I'm going to go back to my console and republish. Whoops. There you go. Hit enter. Did I do the thing? Oh, I did 500, not 5,000. That wasn't very visible at all. Okay, there you go, 5 seconds, right? So you can see I hit enter, but I published an event, and I'm hoping somewhere in the world somebody's handling that event. But now I'm stuck in the same time, in the same thread, and hopefully in the same transaction, waiting for that to finish. Maybe I don't want that. There are ways to get around that, right? I could certainly make this at async. That would be nice, but now this happens in a separate thread. And I lose, if I had one going, I lose the transactionality that I had before. I could do this. This is nice. This gives me at transactional. It'll start a new transaction. But really, that's not what I want, right? Because I could still end up in an invalid state. I could publish an event, have it get handled in one side, and then consume it in the other, and the event will, the machine loses power right in the middle of the dispatch, and then I've got an invalid state. I've adopted the dog, but not scheduled the checkup. So I want some way to get the best of both worlds. I want decoupling through messaging, but I don't want to be synchronously coupled, and also I want to make sure that this gets handled eventually. So we're going to use Spring Modulith's application module listener. Okay, this is semantically, it's equivalent to the things I just showed you, but it pairs super nicely with some extra configuration here, quite like a Vegemite and beer. Okay, so we're going to use that. We're going to initialize a schema, and I'm going to go ahead and restart the application. Hit enter. Okay, and when I do that, I go back over here. I refresh. There you go. I've got this table now called event publication. Yeah, and this event publication table. Refresh that again. Refresh that. You can see I've got the ID, I've got the listener ID, that's dogtour.checkup. I've got the event type, dog adoption event, serialized representation of the data in the event, the publication date, and of course the completion date is null, but it's been 5 seconds, so if I refresh, it's now not null, okay? So what I've done is I've got a table that allows me to dispatch events from one module to the other in the same code base and guarantee that it gets handled eventually. This is called the outbox pattern. What you do is you use a transactional ledger, like a database table, to keep track and maintain the consistency of something that is not transactional, like, in this case, an asynchronous non-thread thing, or maybe a file system, or whatever, right? This is a very, very common pattern, and we implement it for you here. This is great for module-to-module communication, but of course, if you actually want to communicate to other services, if you want to publish things to other services, well, we've got you covered there as well. You can take that event and add @externalized. And if you've set up the requisite integration in Spring Modulith for RabbitMQ or Amazon SQS or Kafka or Spring integration, then you just specify the Kafka topic, or you specify the destination routing key in RabbitMQ, or the Spring integration message channel name, etc. Right? Put all that stuff here in this schema, this little string here, and it'll automatically also publish this thing in addition from one component module to another, but also outside externally via a messaging substrate of your choice. okay? So now you have the best of both worlds. You're building modular code, but you can also scale out to build a distributed system as well without having to refactor any major parts of your code. So I think this is quite nice. I think we've done a pretty good job. We've got a modular system. Remember, one of the benefits of that config property that I showed you there is that it republishes outstanding events. So if I go here, publish that again, and then I'm going to stop the process, right, and kill it. Here we go, goodbye. You can see it's been turned off. Restart. I've got a missing event, surely, right? So it's going to reprocess the event here that I published that hasn't completed yet, right? So wait 5 seconds. There you go, stop scheduling, right? It actually ran that when the application restarted. It made sure that I got any missed messages and handled them, okay? So now I'm guaranteed that things completed when they should have. So I've got a modular system. I think we're doing good. I keep saying the word modular. What does that mean? Well, we can actually write a test to sort of suss that out. So let's go over here. And I'm going to ask var application modules, okay, .class. I'll say app verify. I'm going to print out the modules. I can even document the modules. Imagine that, writing documentation on purpose. Here we go. Ready, steady, go. So the test is green, neat, and I've enumerated the logical structure of my code. I can see here that I've got these modules called adoptions. Logical name is adoptions. Base package is this. The packages are that. Here are the bean dependencies. Here's the other package. Here's the dependencies, the modules, etc. And even better, remember, Spring Modulith knows the arrangement of my code. It knows how things are strung together and how they're wired together. So it can help us write a C4 context diagram, a model diagram that shows us the component boundaries of the system, right? And so this evolves with your system. Pretty neat, huh? Now I've got an architecture diagram that stays in sync with the code. This is as opposed to the common thing you see where you log into a wiki page and there's some diagram from some well-intentioned architect from 2.5 years ago that has long since diverged from the actual state of the system. Great. So we've got a modular system and we've adopted this dog. It's not the flex you think it is, by the way. I now have 2 terrible dogs, right? So it's not good. But anyway, we've done it. We've adopted this dog. But how did we know about this dog? I saw him on the news. He went viral. That's not how most people adopt dogs. Like, there's a conversation to be had. There's questions to ask. You want to know about the pedigree and the history and the families and whatever of this dog, the health, etc., of this creature. So normally you're going to have, you want to be able to ask questions. In order to support that, I want to build an assistant, okay? So we're going to build an assistant here in a separate class in the same module package. And I'm going to use Spring AI's chat client. I'm a big fan of this chat client. It allows me to talk to a chat model. But like I said, I'm a huge fan of this of the chat client. Big fan. Just a huge fan of the chat client. I believe it's going to do good things for you. Okay. So let's create that, and I'm going to create an assistant, and I'm going to talk to a chat model. Like I said, and that chat model is auto-configured for you by Spring Boot and Spring AI based on the starter that you've got in the class path. I happen to have Spring AI's OpenAI support on the class path. In order for me to use it, I needed to specify an OpenAI API key like that. But I'm not going to do that here live in front of you, friends. I've already exported an environment variable before I got on the stage, and it's in my shells process. So I have that key in shell scope, and it'll get normalized and made into that property. So forgive me for not leaking my API credential. Just trust that it's been done, okay? So now, I'm going to create this assistant, and I'm going to ask this chat model, who's going to be our representative for our fictitious dog adoption agency called Pooch Palace. I'm going to ask it questions about these dogs. I'll say, do you have any neurotic dogs? Right? And I'll say, give me the response call, and I'll get the content as a string. I'll assign that to a variable there. I'm going to say var, and I'll just print this out, system out content, voila, okay? There's the response from the model, Wi-Fi permitting, here we go. And, let's Alt-tab that, good, look at that, good. So if I go back to the console, here, surely, oh, I need to define what did I do? Oh, I've got 2 beans called assistant. So let's runner, okay, Alt-tab just to force DevTools to go. Start that again, let it talk to the internet. Here we go, come on. There we go. It says, I don't have any dogs, but I can offer some advice or information if you're dealing with a neurotic dog. So clearly, well-intentioned response from the model, which is probably thinking we're just out of our gourds, asking about pets. It doesn't have pets, it's a computer, right? It's being as polite as it could in that situation, but how else would you respond? So it doesn't know about what it's trying to do. It doesn't know that it's supposed to be a representative for our fictitious dog adoption agency named Pooch Palace. We need to give it something called a system prompt that will inform, that will frame its answers to us. In order to do that, we have to get a system prompt. I happen to have a system prompt here on my local machine here. So there's a system prompt. I can get the information. I can paste it to the clipboard and then paste it in my IDE. You know what? That doesn't feel right. That's wrong. Let me try this again, okay? Sorry. Dog. There we go. So that'll give me the content there, okay? Var system. Paste that in there. Voila. And I'll say default system prompt. Paste that in. And now, having done that, Alt-Tab, go back here. Come on. Okay. There you go. It says, I'm sorry, but we currently don't have any specific information about neurotic dogs available for adoption. If you're interested in adopting, please check back later. Visit one of our Pooch Palace locations. Much better. Still not giving us our dog Prancer, but at least it's acting like it should be able to, right? You might even think you're talking to someone who is behind a console that, for whatever reason, is unable to bring up the catalog or the inventory, the dogalog of dogs, okay? So what I want to do is I want to actually like connect this thing to our data, and that, my friends, is the really main value proposition here. Remember, AI is not about Python and building models. AI is about integrating models, okay? And Java is second to none here. And where is your data? And what are the services building and guarding that data? Probably in Spring. You have a wonderful opportunity here. We all have a wonderful opportunity here. Spring AI gives us the ability to enjoy and appreciate and integrate these AI engineering practices to leverage these different models and integrate them into our line of business functionality. Okay, so this is what I want to do. Is I want to get this model access to our data. And that data, as you know, lives in our SQL database. So I'm going to inject the dog repository, and I'm going to give it access to the data. But in order to do that, I want to send only a subset of the data that makes sense for the query, not all of it, right? Because there's a complexity cost, if not a dollars and cents cost, to sending data to these models. So I'm going to take the data from the repository, and I'm going to write it out to something called a vector store, which is a data structure that's optimized for similarity searches. I can sub-select only the things that are sort of pertinent and write that out to the vector store, or write that out to the model after doing a sub-selection in the vector store. So I'm going to create a Spring AI document, and the document is it's just data, any data. It's just strings in this case, right? I'm going to create ID colon, I'm doing a string formatting, right? ID, name, and description, like this, okay? And I'm going to put that in the string. There's no schema here. There's just any kind of string you want, like that. And I'm going to write that out to the vector store like this. So list.of, pass that into the document, etc. Now, I'm also going to tell Spring AI to initialize the PG vector store schema. So I'll initialize that as well. And I've been looking at this code. You know what? It doesn't feel right, obviously. This is a document about dogs. So document. Document. IntelliJ, I swear. Okay, very good. Okay, so I think we did good there. Let's go ahead and let it run. And it's going to initialize the schema. It's going to take a little while. It's actually calling an embedding model on the internet. It's going to get back some responses. And eventually, it'll put those responses in this table that it's got over here in the vector store functionality in Postgres, right? It's got embeddings and all that for our data. And eventually, it'll come back with a sub-selection. Here we go. There you go. We don't have information, ID, name, description. What is that? It says we don't have any information about the neurotic dogs at Pooch Palace. How curious. ID, name, description. ID, name, description. Try again. Oh, but let's not reinitialize everything twice. I don't want to do that. That's costly and expensive. I mean, time-wise. Okay, restart. Did I restart the test? Wrong one. Let's restart the actual program proper. There we go. This time with more gusto. That's a bummer. What did I do wrong? So we got document, ID, colon, name. We can always just print out the results, surely. Okay. Formatted, system out, formatted. And then, actually, wait, what do we have in the vector store? Look at that. ID, name, Bailey, description. I feel like I did my part. Why didn't it do its part? Okay, let's go back here, remove that to this. Okay, all the data's there. Oh, you know why? We didn't give it access to the data. I forgot. I want to write a retrieval augmented generation pipeline. I need to connect the client with our data. In order to do that, I'm going to use an advisor. And there are many different advisors you can use. This is like an interceptor or a filter. I'm going to create a default question answer advisor, and I'm going to point that to our vector store. Okay, so I'll just Alt-Tab, come back to this, let it run again. And remember, this is going to support querying the vector store for information and then sending that in the response. So there we go. Yes, we do have a neurotic dog available for adoption. Prancer is described as a demonic, neurotic dog that has some specific dislikes. All of them. If you're interested in learning more or meeting Prancer, boy am I, feel free to reach out to us at Pooch Palace. So this is great. So what I did, remember friends, I woke up this morning and I said I want to write a retrieval augmented generation pipeline. I wrote one line of code and I got a retrieval augmented generation pipeline. What did you do this morning? okay? Now, I think we've done a good job. We've got AI, we've got modularity. I think we're in a good place. It's now time to focus on production. And actually, before we do that, I just realized I want this also to be in a format that I can use. I'm getting back a response that's a string. Strings are no way to build an abstraction. So what I'm going to do is I want a nice type-safe thing. I'm going to build something called a dog adoption suggestion. Int ID, string name, string description, okay? And I'm going to ask Spring AI and the model, the client rather, to send this back to us here. I'll say entity, that, and then I'll turn it back into a type-safe response. Alt-tab, okay? And you can see if I go down here, it's given us a nice type-safe dog adoption suggestion. ID is 45, name is Prancer, description is blah, 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 okay? And this variable is also cast to that dog adoption suggestion type there. Okay, so now I've got a modular system with AI integration and assistant. I think it's time to turn our gaze towards production. And here, my friends, we have 3 very important questions that we need to ask. First and foremost, is our code efficient? Is it efficient? Well, of course, it's in Java. Of course, it's efficient, right? How many of you have seen this wonderful study done by some Portuguese back in 2018 BC? And this blog asked the question, which programming languages use the least electricity, right? And these numbers, I think, are not all that surprising, but we'll go through them anyway. You've got C. It's the most energy efficient for machines, not for people, definitely not for people, okay? Moving on. You've got Rust, well done, zero cost abstractions, very nice, coming in quite high there, good stuff. You've got C++, pooey, disgusting, disgusting. Moving on. Ada, nobody cares, and then Java. And Java's in the top 5 most energy efficient languages, okay? Top 5, nice. And by the way, keep in mind, the first 4 are compiled. Java is a virtual machine. Quite good. Well done. We can say that Java is twice as inefficient as C, okay? Good stuff. You've got a bunch of other languages I quite like. C# is pie. I love pie, right? Delicious. You've got Go, Away. You've got JavaScript and TypeScript. How, in what universe does a compiler that optimizes and forecloses upon execution possibilities result in code that is 4 or 5 times less efficient? That should not be the possibility. That should not be even a universe of possibilities. Leave it to JavaScript, right? Don't apply a reasoning from the real world to JavaScript. Nothing good will come of it. Moving on. These 2 disgusting languages, the less said about which the better. Moving on. And then you've got JRuby and Ruby. JRuby is Ruby in Java, and Ruby is Ruby in C. And yet JRuby, by dint of having been built on the JVM, is almost 1/3 more efficient than Ruby. We have an amazing platform, my friends. Never let anyone tear it asunder. So yes, the code is quite efficient. Moving on. Is it scalable? Is it scalable? Well, by dint of, to the extent that scalability is a function of our ability to start something, finish it, and move on to the next thing, yeah, of course Java is scalable because it's fast. But remember, so much of life is not about what we are doing, but the things upon which we wait. And if you're waiting for things, externalities like microservices and data and whatever, then you're going to be waiting on threads, statistically. And if you do anything on those threads that isn't actually I/O, that isn't actually CPU bound, then that's a mismanagement of resources, right? It's not good. Wasting threads is really a waste of your potential of your service and your production environment. So what I want to do is to integrate some way to have my cake and eat it too. I want to be able to use regular I/O and do regular I/O kind of things, but not sit there on the thread unduly wasting time. So what I want to do is I'm going to actually use Java's virtual threads. And it's very important to see just how good they are, right? Virtual threads are amazing. So I'm going to show you an example from my friend Cora. She's super, super smart. And she's got this demo that I steal from her. You can follow her online or wherever you find her. Her Twitter, I think, is this. She's like brilliant, right? And she did this demo. And basically, what I'm going to do is I'm going to create an endpoint here called delay and string delay. And I'm going to use the Spring Framework REST client, private final REST client, okay? HTTP, add that into there. And I'm going to say this.http.get.uri, and we're going to say https http bin.org delay 5. And that's going to artificially prolong the time it takes to produce a response by the number of seconds stipulated in that URL there, okay? In order for this to work, I need a REST client bean. So I'll do that here. I'll say REST client.builder. Oh, come on, Josh. Do the thing. Builder, voila. And I'll say return builder.build, okay? Good. And I'm going to just go ahead and start this application up. I'm going to do some load testing, okay? Some benchmarking. So I'll say, hey, minus n, that's 40 requests, concurrently 20, going to localhost, okay? 8080/delay, okay? So that's, it's going to make 40 requests concurrently, as many as 20 at the same time. Sorry, 40 requests total, but as many as 20 concurrently at the same time to that local thing. That in turn is going to do I/O, contacting the service that is going to artificially respond in 5 seconds. I forgot to do one more thing, friends. I forgot to do one more thing. I need to dramatically curtail the scalability of the system. Remember, my system is freaking amazing, okay? It really is. I have an amazing computer. So, you know, it's just a top-of-the-line machine. It's actually freaking amazing. I can run both Slack and Teams at the same time. At the same time, okay? I can do that now. The science, you wouldn't believe it, what the scientists have done recently. So I have a very, very fast machine. I want to simulate something that is more akin to production, where you have like 0.1 vCPU or something like that. I want to like dramatically curtail my scalability by forcing contention in the threads, okay? So here we go. Here's without virtual threads, okay? Here's the bad result. Let's do that. Yeah. Okay, we're going to come back to this. And now I need to refactor my code to take advantage of virtual threads. And look, I'm a big believer that if we persevere, if we put our heads together, we can do anything, okay? And it might take a little while to do it, but okay, it's done. So let's go back over here. Here we go. Whoops. Do that again, okay, with the virtual threads enabled. I'll take some water. Come on. Hurry up. It's not like people are waiting. Come on, hurry up. Okay, very good. So there's the with virtual threads numbers, okay? Yay. There. So 13 versus 22. So almost double in terms of total time taken without virtual threads and versus with. The slowest was more than 300% of the fastest without virtual threads, but with virtual threads, it was like 2.5 seconds slower. The fastest is about 5.2 in both cases. The average without virtual threads is almost 10. It's almost twice. But the average with virtual threads is 5.9. It's free scale. You enable virtual threads, you scale. Save the turtles. It's a good result, okay? It's an amazing result. All you have to do is upgrade. Upgrade to Java 21. This is, by the way, soak this up. Read this in. Remember, this is such a rare thing. I didn't have to do async await. I didn't have to do suspend functions. I didn't have to do any of that nonsense. This is the first time, and probably the last, let's be real, the first time we've ever had something in the Java ecosystem that is not just as good, but markedly better than what the other languages have. Enjoy it. Oh, just breathe that in. Just enjoy this for once, okay? Just enjoy it. It's not going to happen again. It's amazing, okay? So we have an amazing result here. Free scalability just by upgrading to Java 21 and later. So we can say, yes, Java is scalable. Next, is it fast? Well, friends, unlike my talks, Java is very, very fast, okay? How many of you saw the 1BRC challenge? This is a thing where my friend Gunnar Morling asked people to submit a program that reads 1 billion rows of weather station telemetry data, you know, city, semicolon, temperature, to read that data and then compute some statistics and dump it out into the command line. Well, this program, you know, he got hundreds of submissions. How fast do you think the fastest one? By the way, no frameworks, no libraries, just JDK. How fast do you think the fastest one was? I've heard like 10 minutes, I've heard 20 seconds, I've heard lots of numbers, but the actual number is even better than that, right? So you go here. Okay, maybe not. Come on. The actual fastest result was 1.5 seconds, right? 1.5 seconds to run, start to finish. You hit enter, 1.5 seconds later, it's unmapped all the memory and printed out the computer results. Java is very fast. It's very, very fast. But bear in mind, the first 3 implementations are all using GraalVM native image technology, AOT, okay? And the 4th one is using OpenJDK at 1.8, but these first 3 are using GraalVM. So I think GraalVM is a pretty good idea. In order for us to use it, though, we need to make sure that wherever we do sort of unconfigured reflection, that we account for that. So let me take this, and I'll say register for reflection binding, and I'm going to go ahead and kick off a native compilation, okay? Do this. Did I actually configure native compilation? I'm sure I did. Graal? Yeah, there it is. I chose GraalVM on the initializer. I'm going to run that compilation. I'll let it do its thing in the background there. And the only problem with GraalVM is that it just takes a long, long time. You have to sit there waiting for the compilation. I understand, very sadly, this joke now. I never thought I would be one of those people that gets this joke. The #1 program excuse for legitimately slacking off, my code's compiling. I thought this was for the C++ people. I didn't know it applied to us, right? We have to wait a long time for these compilations because it's doing an analysis where it prunes any extraneous things. And I get really bored, and it kind of reminds me of that interminable music you hear in the elevators or lifts where it just has no start and stop called elevator music. It's meant to just keep you sedated as you wait endlessly for this lift to get to where you're trying to go. And I thought, gosh, wouldn't it be great if everybody else could hear elevator music when they do these native image compilations? So I went to Oracle, and I said, Oracle, please play elevator music during the native image compilation process. I said, Oracle, I already hear elevator music in my head when I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. I got some great responses. This person said, why don't you use this soundtrack from the Nintendo 64 adoption of Pierce Brosnan's first outing as James Bond called GoldenEye. Brilliant idea, great music. Somebody else said, why not have beeps? Yeah, that's a great idea. That's a freaking brilliant idea. Even my stupid microwave makes a ding sound. Imagine, you start compiling, and a few minutes later, you get a ding, code's done. Wouldn't that be great? I love that idea. And then finally, I got this one. Thank you for your feature request. And this is from my friend, Dr. Fabio Niephaus. He's a doctor on the GraalVM team, one of my favorite doctors, along with Doctors Who, Strange, Sue Subramaniam, Sire, DeVolder, and Pollock. And he responds, he says, thank you for your feature request, Josh. The problem with playing music during the compilation is that it's just fixing the symptoms, and we've been in our store working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Go on. I have prototyped the -- Josh Long mode. So what this would do is you'd compile the program. You'd kick off the compilation using native image compiler, which is what the Spring Boot plugin is doing. You're hearing music. You're not sure why this is happening to you. Who did this to you? Where's the music coming from? You're confused, but now you see music brought to you by Josh Long. Okay, you're in a state of calm and collectiveness, but you're still bored, still waiting for this thing to finish doing its work. You want something nice to look at, so then it would print out a picture of me in my Spring. This is me, right? I'm in my Spring shirt here. Yeah, so I'm not sure when this will get merged into the compiler. Surely soon. What were we talking about? Oh! Right, the compilation, yes. Oh, that is awkward. That's awkward. That actually finished like 5 minutes ago. That's embarrassing. That actually has been done for a long time. Awkward. Okay, moving on. So here we are, du-HS. Here's the binary, 103 megs. That includes the JRE and everything. I'm going to run that. Oh, port conflict. We'll go over here. Stop it here. Here we go. Start. There we go. 0.2 seconds to start up. And much more importantly, we have this process identifier, PS-O RSS. You divide that by 1,000 because it's kilobytes, so 173 megs, to build an application that is scalable, it has AI, it has modularity, has a runtime, it has all the code from the JRE that it needs, and is really, really good. So I think we did a good job, my friends. We have built a service that is worthy of production, and I have 2 terrible dogs. Thank you so much for your time. Thank you so much. I appreciate you. Have a great show.